Problem tells us that a power adapter uses a transformer, several diodes, and a capacitor to convert high AC voltage into low DC voltage. And we're asked to examine the power adapter and figure out what ratio of turns is in the transformer and what percentage of the electrical energy input becomes electrical energy output. So first, the ratio of turns. Previously, we've said that the voltage on the secondary side of a transformer is equal to the voltage on the primary side of the transformer times the ratio of the number of turns on the secondary side to the number of turns on the primary side. So if you take that and divide both sides by primary voltage, you can rewrite it to say that the secondary voltage divided by the primary voltage is the same ratio as the number of secondary turns to primary turns. And reading the adapter, it's pretty hard to in the capture here in the printout, but it's easier than the slide. The secondary voltage, so the output voltage is 9 volts in this particular model, and then it's made to be plugged into a 120 volt outlet. So the ratio, therefore, volts is going to cancel volts, is 9 to 120. So what that means is in this power adapter, the transformer on the incoming side, for every 120 turns there is in that coil, there need to be 9 turns on the secondary side. So you could do different amounts here. You could do 40 turns on the primary side, 3 turns on the secondary side, 80 and 6, or any multiple as long as you keep that ratio. The second part of the question wants to figure out what percentage of the electrical energy input becomes electrical energy output. Theoretically, and often in the physics world, which we do some of these calculations, we just treat energy like it's conserved and transformed completely. But in reality, if you've used one of these power adapters, they warm up with use, and that's telling you that a portion of your incoming electrical energy is actually being converted to heat. How much in this particular model? Well, to do that, we need to actually compare the power in to the power out. So power in is going to be voltage in times current in. So that is 120 volts. We're told the incoming current is 250 milliamps. That's 0.250 amps. So that incoming power is 1/4 of 120, or 30 watts. How much power out do we have here? Well, similarly, power out is going to be voltage out times current out, and we get 9 volts out of this device, and the current that it delivers is 1000 milliamps, and that's 1 amp. 9 times 1 gives me 9 watts. So only 9 out of 30 becomes the electrical energy, and the rest is going to be dissipated as heat in the system. 9/30 is 0.3, so that means 30% is electrical energy output.